I'm going to start by moving this to the opposite side. So when I move it over, it was positive. When it moves over, it becomes negative. And now this looks similar to what we've been working with. I'm going to square both sides. On the right-hand side, I'm left with x plus 7. I need to write this quantities twice. Okay, so on the right-hand side, I'm going to FOIL. Multiplying the fronts, I end up with 49. A negative times a negative for the last is a positive, and the square root of x times the square root of x is simply x. Now, when I do the O and the I have negative 7 square roots of x, and again, negative 7 square roots of x. So negative 7 and negative 7 is negative 14 when you combine. My goal is to get this by itself. So in order to do that, I'm going to move the other items to the left using inverse operations. Cancel and cancel. I'm left with negative 14 square roots of x equals, the x's cancel, and a negative 49, and a positive 7 is a negative 42. So now I ask myself, like, should I square both sides? Can I divide? So let's see. If I take 42 and divide it by 14, I get a nice answer of 3. So in this case, I think it's going to be to my advantage to divide both sides by negative 14. 3 equals the square root of x. I'm going to square both sides. 9 equals x. Now, does this guarantee this is the answer? It does not. So I'm going to come back up here. You can see my screen. I'm going to take the square root of, again, 3 was my answer. Just check, or 9 was my answer. 9 plus 7, move it outside, plus the square root of 9. Now, this better equal 7. It sure does. That means that 9 is the correct answer for this problem, which is number 11 from various equations 2. Same thing, I'm going to move this to opposite side. So square root of negative 2x plus 10 equals 3. Now this was negative. When it moves over, it becomes positive. Just like number 11, I'm going to square both sides. On the right-hand side, I'm left with negative 2x plus 10. Now over here, I have 3 plus x plus 4. And 3 plus, again, square root of x plus 4. Let's FOIL on the right-hand side. Multiplying the fronts, I end up with 9. Multiplying the backs, I end up with positive x plus 4. I have 3 groups, and 3 groups would combine to give you 6 groups of the square root of x plus 4. And I want to isolate this quantity. So I'm going to move 9 to the opposite side. I'm going to move x to the opposite side. And 4 to the opposite side. 9's cancel, x's cancel, 4's cancels, and on the right-hand side, I have 6 times the quantity, or times the square root of x plus 4. Now there's 5 different things on the right-hand side. I need to combine like terms. Negative 2x and negative 3, or negative x is negative 3x. Again, negative 2x, negative 1x. Positive 10 and negative 4 is positive 6. So what is the easiest thing here to do? Now, I could divide by 6 on both sides, but when I divide by 6, I'm going to have a fraction. I don't want to work with fractions. So instead, what I'm going to do is I'm going to square both sides. Negative 3x plus 6 times negative 3x plus 6, and 6 times the square root of x plus 4 times 6 times the square root of x plus 4. Okay, on the right-hand side, we are going to FOIL this out. Negative 3 times negative 3 is 9. I have negative 18x and negative 18x, and 6 times 6. 6 times 6 is 36, and the square root of x plus 4 times the square root of x plus 4 is just x plus 4. Distributing the 36, now 36 times 4, what does that give you? 36 times 4 is 144. Okay, I'm going to subtract negative 36, subtract negative 36, subtract 144. Now, why am I moving it to the left? Because I want to move to the side that has the x squared. Negative 36 and negative 36 combines to give you negative 72. And if I take a positive 6 and a negative 42, I end up with negative 138. Now, are all these divisible by 9? I don't know. Or divisible by 3? I'm going to check. 72 divides, oh, sorry. 72 divides by 9, beautiful. 138 divides by 9, oh, that doesn't work. Let's try 3. 72 divides by 3, 138 divides by 3. Okay, so I'm going to divide by 3. I'm going to divide by 3 here. 3 divides by 3 to get 24. I'm looking at the calculator. Divide by 3 to get a 46. Okay, what does this look like? Well, when I divide by 3, I get 3x squared minus 24x minus 46 equals 0. This is the trinomial I'm trying to solve. Okay, so is this factorable? Let's check and see. 3 times 46, so I have a negative 138 and a negative 24. And so I'm literally just going to start trying 138 divided by 2. So 2 and 68 do not combine to give me somehow 24. 138 divided by 3. Okay, 46 and 3, no. 138 divided by 4. Nope, 138 divided by 5 won't work. Divided by 6, okay. 6, that doesn't work. 138 divided by 7, 138 divided by 8, 138 divided by 9, 138, 10's not going to work, 11's not going to work, maybe 12, 138 divided by 13, by 14. Oh, I'm starting to get worried here. Maybe I made a mistake. Let's go back and look at my work really quick and see. So let me come back up here and just check. Let me start to make sure that I wrote the problem down correctly. So that is negative. That is negative. All of this is right. I add this to the opposite side. Okay, so I did that right. I multiply to get 9. I have 2 quantities. Multiplied. All of that is correct. All of this. So this line right here is correct. Okay, I move this over. So subtracting 9, I move this over, subtracting x, I move this over, subtracting 4. So when I combine 10, oh, here's maybe my mistake. Here we go. So look at when I combine these basic integers. So I have a 10 minus 9 minus 4. When I combine these 3, I end up with negative 3, not 6. So there was my mistake. There was my mistake. So I'm going to come back here and turn this into negative 3, and turn this into negative 3. Now that's going to adjust things for me. So I'm going to scoop right down here while I do this. Okay, you ready? When I FOIL this out, I get 9x squared, and then I end up with, let's check this just to make sure, that's a positive 9x, and a positive 9x is an 18x, and I get a positive 9 in back. And then again, when I went through and I multiplied these, I got 36 times x plus 4, okay? So 36x plus 144. Okay, all good with this so far. Okay, now I'm going to move it to the opposite side. Minus 36, minus 36, minus 144, minus 144. Hopefully I don't find another mistake in my work. Okay, so if I take a negative 144 and I'm going to add to it a positive 9, I end up with a negative 135. Okay, let's see if this gives me an answer that is more desirable. 1 second. Student just had a quick question there. So, okay, what am I doing here? I'm going to start by, okay, recognize I can divide by 9 here. 135 divided by 9. Ooh, perfect. I can divide out a 9. I want to do here. So divide by 9 to get 15. Okay, looks much better. Now, when you divide by that 9 that you factored out, you still end up with 0 on the right. And now I only have to worry about this very simple trinomial. So what multiplies to give us negative 15 and combines to give us negative 2? Being different signs, that would be a negative 5 and a positive 3. Multiplies and combines. So we have one factor of x plus 3 and a different factor of x minus 5. I'm going to set each one equal to 0 to get negative 3 and to get positive 5. It doesn't guarantee that they're both the right answer. Let's come back up here and see. This is our original problem. Unfortunately, again, I made that mistake. Let's start with the square root of negative 2. Let's substitute negative 3 as the first one. Now moving back, subtract the square root. Again, when you plug it in, please put it in parentheses. Now this must equal 3. The left side must equal the right side if this is a true math statement. It does. That means negative 3 is a solution. Then I have the square root of negative 2. This time I'm going to substitute in the second solution, which we got was 5. Subtract the square root of 5 plus 4. And again, we got negative 3. That is not the same thing. Negative 3 does not equal positive 3. That means I only have one answer, and that is at negative 3. That is the only answer that is justified for problem number 12.